friends, welcome to Success Bridge YouTube channel. So in this video we learn about the logic gates. What are logic gates? The logic gates are basic building blocks of digital system. So these logic gates are the electronic circuit which consisting of one or more inputs and one output. Now the inputs and the output of these logic gate can have only two values, that is the logic high or the logic 0. So in reality these high or low are the voltage level. That means the high could be a 5 volt while the low could be a 0 volt. And the relationship between the input and the output of this logic gate is based on certain logic. Let's see the example. When the input is low, where two inputs are low. When the output is high, when both the input is high. From these we conclude that these logic gates have the ability to make certain logic decisions. Let's see. When we interconnect or cascade this logic gate, then this is possible to perform various logic operations. Let me discuss about the why is the output if both the input are 0, the output is 0. If any one of the input is low, then output is 0. If both the input is high, then the output is high. This is the Boolean expression of AND gate. Y is equal to AB. Let's see gates. Types of logic gates. In here, there are several types of logic gates. Let me discuss here. There are basic logic gates. AND gate, NOR gate, OR gates are the basic logic gates. Apart from that, two more logic gates are NAND gate, NOR gate. These gates are known as universal gate. Because of using any one of two gates, it is possible to build any logic circuit or Boolean expression. Apart from that, we have two more logic gates, that is XOR gate and XNOR Gate. So one by one, let's talk about all different logic gates. And first let's start with NOT gate. This is the logic representation of NOT gate. In this, A and B, A is the input, Y is the output. Let's see more discussed with the help of truth table. This is the logic expression of NOT gate. Y is equal to A bar. From the truth table, we see the functionality of NOT gate. A is the input, B is the output. If A is the 0, the output is 1. If the input is 1, we get the output is 0. From this scenario, we can say that this working as an inverter. And along with NOT gate also known as an inverter. Because of this behavior, we say that the NOT gate can behave as an inverter. Let's see the next logic gate. Gate is OR gate. OR gate can have two or more inputs and one output. Let's see, this is the logic representation of OR gate. A and B is the input, Y is the output. Let's more discuss with the help of truth table. A and B are the input, output is A plus B, nothing but Y is the output. See, if both the input are 0, the output is 0. If any one of the input is high, the output is high, or both the input is high, the output is high. How this is from the truth table, we can say that the working of OR gate. This is the Boolean expression of OR gate is Y is equal to A plus B. Now from this expression, let's see how the value or the output we can get. See, Y is equal to, let's see the input. A is equal to 0, B is equal to 0. Nothing but 0 plus 0 is 0. Let's take an example one more. If the input is A is 1, B is 0, then 1 plus 0 is nothing but 1. Let's see. Another gate is XOR gate. This is the logic representation of XOR gate. XOR gate is a digital logic gates which consisting of one or more inputs and one output. Let's see the working of XOR gate with the help of truth table. Here the A and B the input, Y is the output. If both the input is 0, the output is 0. If any one of the input is low, then output is high. If both the input is high, the output is high. From the truth table, we saw how the XOR gate operation is working. This is the Boolean expression of XOR gate. Y is equal to A bar B plus AB bar. XOR gate is also have the property of to detect the even parity and the odd parity. Okay, how we can say if the total number of ones are even, is act as even parity. If the number of ones is odd, then it is act as odd parity. This is nothing but XOR gate can detect the even parity generator. It is work as parity generator. Along with one more property of XOR gate is to detect XOR gate can behave as buffer and the inverter. When the buffer, it will be act when one of the input is grounded and it behave as buffer. When it is act as inverter, when any one of the input is connected to VCC, then it is act as inverter. About the another gate is XNOR gate. XNOR gate have two inputs. This is the logic representation of XNOR gate. Let's see with the help of truth table. If the input, both the input is 0, the output is 1. If any one of the input is low, the output is 0. If both the input is high, then output is high. From this, we can conclude that this is a functionality of equality. equality. It is working as equality. XOR gate can also known as equality gate. By from the seeing the truth table, we can say it is behave as equality. As you can see, when both the input is 0, the input is 1. If the both input is 1, 1, then the output is 1. From that, we can say that this is the equality expression. This is the Boolean expression of NOR gate. Y is equal to AB plus AB bar. Let's see another gate is NAND gate. This is the logic representation of NAND gate. How this NAND gate is made up of or built by the combination of AND gate and the NOT gate. Then the NAND gate is built. This is the expression of NAND gate. Let's see how the working of NAND gate with the help of truth table. A and B are the input and AB bar is the output. Let's see. If the both the input are 0, the output is 1. If A is equal to 0, B is 1, the output is 1. If A is 1, B is 0, the output is 1. If both the input is 1, 1, then output is 0. This is the logic Boolean expression of NAND gate. Y is equal to A dot B bar. Let's see with the help of expression, Boolean expression, we can see the output. If A is equal to 0, B is equal to 0, A dot B is nothing but 0. Then complement of 0 is 1. Then the output is 1. Yes, this is proof that this is the working of NAND gate. The another logic gate is NOR gate. This is the logic representation of NOR gate. NOR gate is built by combination of NOT gate and the OR NOT gate. These are the two inputs. A and B are the two inputs and Y is the output. Let's see with the help of truth table how the behavior of NOR gate. See, A and B are the input. When both the input is 0, 0, the output is high. If any one of the input is high or both the input is high, the outputs are low. This is how NOR gate can behave. The output of this logic gate is 1 only when all the inputs are 0. This is the logic expression of NOR gate. Let's see the Boolean expression of NOR gate is Y is equal to A plus B bar. Let's take an example. If both the input, if A is the 0, B is the 0, 0 plus 0 plus 0 is 0 and complement of 0 is 1. Yes, the output is 1. Now, if the input is 0 plus, when the input is B is 1, then 0 plus 1 is 1. The complement of 1 is 0. Yes, from the expression we can getting the output.